In this video, we'll just go over how to solve a normal electric force problem. So remember that the electric force can be calculated by using this formula, Coulomb's law. It's K times Q1 times Q2 all over R squared. Just remember K is a constant. It's always the same, and it's about 9 times 10 to the 9 Newton meter squared over Coulomb squared. Q1 and Q2 are just the charges. And that's in coulombs as well. And R is the distance between Q1 and Q2. And that's going to be in meters. And all you have to do is plug them in and make sure you type it in your calculator right. So for instance, if I have two charges, and the cool thing is that it doesn't really matter which one's Q1 and Q2. So you can label them however you please. And let's say Q1 has a charge of 4.3 times 10 to the negative 3 Coulomb, and Q2 has a charge of negative 2.4 times 10 to the negative 6, how about that, Coulomb, separated by 3.2 times 10 to the negative 3 meters. And all I have to do is plug it all in and get a number out. And so what you're going to want to do is just set it up. Fe equals K, 9 times 10 to the 9, don't forget your units, times Q1 times Q2 all divided by this is a place where you can mess up, 3.2 times 10 to the negative 3 meters squared. So you can either forget to square it or forget to put parentheses around it when you put this in your calculator. And if we do that, the number we should get, let me actually put this in my calculator. I got 9.07 times 10 to the 6 newtons. Remember just with the units here that I've got 1 Coulomb here and 1 Coulomb here, and they cancel out with the 2 coulombs here. And then I have meters squared here, which cancels out with the meters squared here. So I'm left with newtons. And the important thing to do, and this is my strategy, whatever works for you, remember that like charges repel and opposite charges attract. And so you have a positive and a negative charge in this example, so they're going to attract. And so we know that the force is going to be pointed inward, right? They're going to be forced towards each other with this, the force of this magnitude. Right, so that amount of force going that way. And also from a Newton's third law argument, you can say, well, if Q1 is attracted to Q2 with a force of 9.07 times 10 to the 6 newtons, then Q2 must be attracted to Q1 with the same force. And in general, my advice is to, once you get this number, oh, I'm sorry, see, I even did it myself. This number should be negative, right, because there's a negative here. But what I do is I just kind of take the absolute value. I kind of just do this in my head, make all the numbers positive, and then figure out which direction it's going to be in. And that's going to help you not get confused. And in the next video, we'll go over net force. It's a little bit more complicated.